Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, I will show you on how the algorithm works on the virtual memory. So we have three type of algorithm: FIFO, Bludis Optimal, and LRU. So type of algorithm for page replacement, we have FIFO, Bludis Optimal, least recently used, or LRU. In this slide, I just use BO that refer to the Bludis Optimal. Okay, this is an example. We have three algorithm: FIFO, Bludis Optimal, and LRU. So the reference string that given and used in this example is based on 701 203 0423 03 21 2011701. So this is the reference string. You can refer back to the slides that I already shared with you and to the previous video regarding this example. But in this video, I will go thoroughly or details on how it's work from one algorithm to another algorithm. So first we look at the FIFO, first in, first out. So under this algorithm is based on the ages of pages, how long the pages are in there, and then it will check the backward. Next is Bludis Optimal. So in this algorithm, it use the future knowledge. So that's mean before it decide, we make a decision, we need to check the forward, the future. Second, it replace the page that will not be and then use the longest period of time. So this is for the Bludis Optimal. And the third one, we have LRU. So under the LRU, we use the past knowledge. Bludis Optimal, we use the futures. LRU, we use the past knowledge. Okay, rather than the future. So it checks the backward. Quite similar like the FIFO. And then replace the page that has not been used in the most amount of time. Okay, quite similar. Let's look at the first algorithm, which is the FIFO. So FIFO, you need to remember that it's based on the ages pages and check the backward. So the first string that we have is 7, and in this example, let's say we only have 3 frame 0, 1, 2. Okay, so we only have 3 frames. So this is the string. So the first string we have 7. So 7 will allocate at the first part here, first frame. So now we have 7, and then we have another 2 available here. So the next string is 0. Okay, we have the space here, so we just put 7 0 at here. The next string is 1. We still have this space, so we just put 1 here. Okay, so easy for the first 3 string. Okay, next, this string already full, already used. All of the space already used, 7 0 and 1. So we have another string 2. Okay, for 2, so what you need to do, you need to check based on the ages of the pages. So this one is not a resident. You look at this row 702. This is not a resident. So if this is not a resident, so you need to do the replacement. Okay, because this is replacement algorithm. So it's based on the ages of pages. So you check the longest part. Okay, based on this one, 7 is the longest part. So what you need to change the 7 with the value 2. So the next is 2 0 1. Okay, next point, we have 0, and then check at here. Okay, 0 is the resident. So you just copy, no need to do anything. Okay, just copy. Okay, blank here. Okay, example. Okay, next is 3. 3 is not the resident. 0 is resident, so we just copy. Okay, number 3. 3 is not the resident, so you need to replace. So how to replace? You check back here, find the ages page. Okay, 0 is the ages page. So you need to replace 0 with 3. So now you will have 2, 3, 1. Okay, the next part is 0. 0 is not in the resident. You check backward here. 0 is not the resident. So find the longest. The longest is 1. So replace 1 with 0. So you will get 2, 3, 0. Okay, the next is 4. 4 is not the resident. So you need to do the replacement. So the longest part is number 2. So replace 2 with number 4. So we'll get 4, 3, 0. The next one is number 2. So 2 is not the resident. So the longest is 3. Replace 3 with 2. So now you have 4, 2, 0. So the next is 3. 3 is not the resident. So you should do a replacement. So the longest part is 0. So you replace 0. So now we have 4, 2, 3. Okay, after 3, we have 0 here. 0 is not the resident. Okay, not the resident. So you can replace number 4 here because it is the longest part. Okay, number 4. So replace number 4 with 0. So you will get 0 to 3. So next is number 3. 3 is the resident. So you just copy. Okay, next number 2. Okay, number 2 is the resident. You just copy. Okay, next one is number 1. Okay, number 1 is not the resident here. So you need to replace something in order to put number 1. So based on this ages page, you can replace number 2. So replace number 2, then you will get 0, 1, 3. Okay, next is 2. So 2 is not in the resident. So you can replace 3 to 2. So now you get 0, 1, 2. Okay, 0, 1, 2. Next is 0. So 0 is the resident. You just can copy. Okay, number 1. Number 1 is the resident. You just can copy. And then next is 7. 7 is not the resident. So the longest part is 0. So you can replace 0 with 7 here. So now we have 7, 1, 2. Okay, next is 0. So 0 is not the resident. So you need to replace 0 with number 1. Sorry, you need to replace number 1 with 0. Okay, and then we have here. Number 1. So at the number 1 here, we can replace number 1. We can replace number 2. Okay, 1, 2, 3. Okay, number 2. So you will get 7, 0, 1. So basically, you need to check the ages of the page before you can do replacement on the non-resident value. So at last, this is the process. And then to get the page 4, okay, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So the page 4 is 15. Okay, that is for the first in, first out. Okay, next we have another algorithm that we call as Bludis Optimal. So in Bludis Optimal algorithm, we use the future knowledge. So we need to check the forward and then replace the page that will not be used for the longest period of time. So, okay, the first string we have 7. So 7, we just put 7 here. Okay, the space, another 2 available, so we just put 0 at here. And we have another available space, so we can just put 1 here. So the next value is 2 for string 2 here. Okay, there is no space available, so we need to do a replacement. So how to check, how to get the replacement part? Okay, you need to check forward. Check forward that the page, the use of the use for longest period of time. Replace page that will not be used for the longest period of time. Okay, we have 7, 0, and 1. Okay, this one is 2. So next is 0. So we cannot use 0 because just 0. Okay, and then we have 1. 1 is here. Okay, and then we have 7. 7 is here. So the longest period that will not be used, okay, sorry, the page that will not be used for the longest period is 7. So we can replace 7 with 2. Okay, here, like that. So 2, 0, 1. The next part is 0, so we just can copy. Okay, next one is 3. Okay, 3 is not a resident in here. So 3, okay, which page that we need to replace? 0 is here, 2 is here, 1 is here. So we need to replace 1 with 3. So replace 1, now we have 2, 0, 3. So the next is 0. So 0 is here. So we just copy. Okay, next is 4. 4 is not the resident. So we check forward. Okay, 2 is here. 0 is here. Sorry, 2 is here. 3 is here. 0 is here. So we need to replace 0 with number 4. Okay, next we have 2, 4, 3. Okay, after 4 we have 2. So copy. Okay, and then we have 3. So copy again. And then next is 0. So 0 is not the resident. So we check. Okay, 0. Okay, 3 is here. 2 is here. How about number 4? There is number 4. So we can replace number 4 with 3. Then we get 2, 0, 3. Sorry, we replace number 4 with 0. Okay, 0 is here. Okay, next is 3. So copy. And then 2, copy. And then number 1. Okay, number 1 is not here. It's not the resident. So number 2 is here. 0 is here. So number 3 can be replaced by 1. So we have 2, 0, 1 here. So next, after 2, 0, 1, we have number 2. So 2 is copy. And then 0, copy. And then 1, copy. And then 7. So 7, look at the future. Okay, 0 is here. 1 is here. So we can replace 2 with 7. So now we have 7, 0, 1. So next is 0. So we copy. Next is 1. We copy. Okay, done. So how to get the page full? So we just count 1, 2, 3, 4, 5, 6, 7, 8, 9. The total is 9. So this for the Bludis Optimal. And the last algorithm is the least use. Okay, LRU. So in LRU, we use the past knowledge rather than the future. So that means we check the backward and replace the page that has not been used in the most amount of time. So at the first, we have 3 space available. So easy. Let's put 7 and then put 7, 0 and then put 7, 0, 1. Okay. Next, we already have here 7, 1, and there is no space available. So we look at here is number 2. Okay, number 2. So we check backward. Okay, the longest part. Okay, replace the page that has not been used in the most amount of time. Okay, so 7 here. Based on here, 7. So we replace 7 with number 2. So 2, 0, 1 is here. Next is 0. So we have 0 here as a resident. So we just copy. Next, we have number 3. So 3 here is not in here. It's not the resident. So we need to do a replacement. So how to do replacement? We need to check the backward. Okay, so based on this one, we can replace number 1 here with value 3. So we put 2, 0, 3 at here. Okay, next we have 0. So we just copy. This is the resident. We just copy. Next we have 4. So 4 is not the resident. So what you need to do? We need to do a replacement. So we check back. Okay, number 2. Okay, number 2 is here. 0 is here. 3 is here. So we need to replace number 2. Okay, replace number 2 with number 4. So 4, 0, 3. Next, we have 2. 2 is not the resident. So you check backward. 4, 0, 3. So we need to replace number 3 with 2. Okay, the next part, we have 3 here. So 3 is not the resident. So 4 is here, 2 is here, 0 is here. So we replace 0. So now we have 4, 3, 2. So next part, we have 0. So 0 is not the resident. Okay, 0. Okay, 3 is here, 2 is here, 4 is here. So we replace number 4 with 3. With 0. 0 here. Okay, next, after 0, we have 3. 3 is the resident, so copy. 2 is the resident, so copy. And then number 1. So number 1 is not the resident, so we check. 2 is here, 3 is here, 0 is here. So replace 0 with number 1. Okay, so now we have 1, 3, 2. So next is number 2. So 2 is the resident, so copy. Next is 0. 0 is not the resident. Check. Number 2 is here. Number 1 is here. Number 3. Number 3 is the longest. So replace number 3. We have 0. So now we have 1, 0, 2. Okay. Here is number 1. So we just copy. Next, 7. So 7 is not the resident. 1 is here. 0 is here. 2 is here. So replace 2 with 7. Now we have 1, 0, 7. The next is 0. So 0 is the resident. So we just copy. And then 1 is the resident. You just copy. Done. So the page fold here, you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the page fold is 12. Okay, so that's all for the replacement algorithm. So hopefully you're able to differentiate between the FIFO, the Bludis Optimal, and the LRU. Thank you and Assalamualaikum.